everybody, and welcome to the Arkansas Society of Freethinkers Big Meeting. I'm Chris Borecki, President, and really glad to see all y'all out today. It's icy cold outside, so not much else to do, but I'm glad to see you here anyway. ASF is a nonprofit organization devoted to the separation between religion and state, advocating a scientific and humanistic worldview, and improving the lives of non-believers. You can learn more about us by picking up one of the flyers available at the back table, or by going to arfreethinkers.org. Restrooms, of course, are to the back and to the left after you turn around backwards. And now for our standard disclaimer. Don't think there's anything particularly controversial about Eclipses today, but we read it every time anyway. ASF is a diverse organization with members who represent a wide range of opinions. The speakers who present at our big meeting do not necessarily represent the views of ASF or its individual members. Because we are a 501c3 organization, we cannot directly support candidates for public office, but we can advocate for causes such as separation of church and state, scientific literacy, societal progress, and truthful communication. That said, we'll go ahead with the free thought of the day, which I will go ahead and deliver. And there was an article I read a few months ago about how a lot of times our priorities are about what's going on today, what's going on next week. We're going from grocery list to grocery list, and we never really plan way out in the future. And change is such a constant. You know, the world has changed so much in the past 10 years that it seems like an effort in futility to even think out that far again, to try and be so arrogant as to think that you know anything about what the world will be like 10 years from now or what you can do about it. And so a lot of people take this chaos that we live in, and they use that as an excuse not to make plans, an excuse not to work on big things that take a long time to occur. And my challenge to you today is to think about the next 10 years. Any of you who have walked in here today on your own 2 feet, chances are, actuarially speaking, you have another 10 years that you need to plan for, and you need to think in terms of what happens in the next 10 years, not in the next weeks or months. The risks of short-term mentality are that you never accomplish the big things that take years and years to accomplish. You move from little short-term activity to little short-term activity your whole life, and you never dig in on anything big. So today's thought of the day, number one, is that think big, think long-term, think astronomically long-term if you must, but at least think out 10 years, because you've got 10 years and you need to make something of it. Byrne, did you want to?
I was going to ask you, are you sure the mic is on?
It is on, but the volume might be too low.
I got a text from Roger saying that through Zoom that it's garbled and it's hard to understand.
Okay. That's as high as it goes right there.
Sometimes with
Right there.
handheld mics, you have to eat it.
There we go. We'll eat it. Byrne, did you have anything to add on the free thought of the day?
I can give you one if you like.
You come on up. Please, everybody, give a hand to Byrne Bradley.
At its best, Sunday school teaches kids God loves you and wants you to be happy. Benjamin Franklin said that beer was proof that God loved us and wanted us to be happy. However, H.L. Mencken, who's probably his most famous quote was, democracy is a theory that the people know what they want and deserve to get it good and hard. He had a take on Sunday school that I just found this morning I thought was interesting. A Sunday school is a prison in which children do penance for the evil conscience of their parents. So there you go. There's your free thought.
Thank you, Byrne. So our usual meetings format has a couple of roles, and these are things that you could take on. Just give us a shout if you want to do one of these roles, like free thought of the day. If you come up with something, a quote, a story, whatever you have that will something worth sharing that's kind of funny or kind of interesting or insightful, please give us a shout, because we love to fill these slots with the members, and it's your opportunity to get up and share something. One of the options that we have is Skeptical Sidebar, which is just a quick, maybe 10-minute presentation that any of you could do about a skeptical topic, like some misinformation going around. I don't know where you might find something of that. Maybe check your pocket and see if there's a device in there that's spewing misinformation out, and just pick one of those things up and debunk it, and that's what we like to hear. Another option that we have is called the member story, where you get to share something about your life. You get to share something about your experiences, how you became you, how you traveled to end up to this point where you are today, and this person that you are today. And today's member story is going to be delivered by Liz Forrest, who's our treasurer, and let's give a warm hand to Liz.
So it's a complete coincidence that Vern brought up Sunday school, because I was going to talk about Sunday school and why I'm grateful that the church made me go longer to Sunday school than my siblings. I grew up in North Jersey, right outside of New York City. My town, from what I hear in the last census, it's pretty diverse now. It's only about 92% white. So everybody in town was Catholic or Protestant. If you were even the girls from India were Catholic. Like everybody was Catholic or Protestant. I was Catholic until I hit the age of reason. Stole that joke from George Carlin. That wasn't mine. But my brothers are 9 and 10 years older than me. My sister's 5 years older than me. John and Tommy, they went to Sunday school. They made their confirmation in 5th grade. And they were out. They hardly ever went to church again after that. My sister, 5 years older, she went until 6th grade. She hardly went to church after that. The church started to notice that these families, as soon as their kids made confirmation, stopped going to church. We went every Sunday, front row, Monsignor Gahuli, fire and brimstone kind of priest. And they decided that they were going to make us go longer. So I had to go until 9th grade. So not 5th grade, 9th grade. I thought it was torture at the time. I hated Sunday school. My class was great, though. We were they always did alphabetical order. So we always had the same class. And my class, we were the Bart Simpsons of the Sunday school. We questioned everything. Does my dog go to heaven? Does my cat go to heaven? Why am I considered bad and they're not? Why is that religion? They're not going to go to heaven? We questioned everything. 2 teachers never came back after they had our class. 8th grade, they made us take a confirmation test to make sure we were ready to be confirmed. The entire class failed. And I told this story another time, but the nun came in screaming and yelling. I mean, that teacher slept the whole time. That was Monday evenings. It wasn't Sunday school anymore. He slept the whole day. No wonder why we all failed. So the nun comes in screaming and yelling. Sister Margaret, we called her Attila the nun. And she was screaming and yelling at all of us. And, we're all just kind of sitting there. And then there's me. And she's like, yes. We all failed? Isn't that the teacher's fault? Oh, she didn't like that. She went off all again. But when it came time the next year to actually take confirmation, I had hit the age of reason. I questioned my faith. I didn't believe these stories from the Bible. We were Catholic. We didn't actually read the Bible. That was just kind of whatever stories they pick and choose for us. But it seemed like a bunch of baloney to me. And so I went to confirmation. I got all dressed up. I stood there with all my friends and classmates. But I didn't say the words. So I have a piece of paper saying I've been confirmed. But in my heart, I know I didn't do that. I didn't take confirmation. I stood there and I kept my mouth closed. And so I was really grateful, because if I did it in 5th grade or 6th grade, I would have just sat there and said the words like everybody else. I hit the age of reason, and I was like, not for me. And that was my share for today. Thank you all.
Thank you.
Thank you, Liz. That was great, actually. I can relate to a lot of that in my own life, sadly enough. Excellent. So now it's time for our main speaker, Dr. Scott Austin, who is an astronomer and is going to talk to us about the next eclipses visible from Arkansas, so that we can all set our schedules and know what to expect and that sort of thing. And let's give a warm welcome to Scott Austin.
I'm not sure I'm going to need this. So. Okay.
Real loud.
Well, thanks for having me. Are we good on sound, Jim? Okay. So I don't have any Sunday school stories to tell you. And I'm not going to ask you to think more than 10 years out. I'm just going to ask you to think about out to 2024. Okay. Because that's when the big eclipse will be happening. So basically what I'm going to start off with is I'll go over exactly what a solar eclipse is, exactly what sort of conditions have to be satisfied to have a solar eclipse, and then I'll get into I'll talk a little bit about the 2017 eclipse that we had, and then get into the next solar eclipses that are going to be visible here in Arkansas, what some of the plans are, some of the things to expect on those days, especially during the day of totality. So let's go ahead and go to the first slide there, and then we'll start talking about exactly what all do you need to have happen so that there's a solar eclipse. Well, first of all, a solar eclipse, if you don't know, is when the moon's shadow hits the Earth, okay? And so if the moon shadow is hitting the Earth, then a solar eclipse is happening. So one of the criteria that you need here is the moon needs to be at what we call new phase, okay? Notice the moon has to be between the sun and the Earth. Now, of course, this diagram here, it's not to scale in terms of the sizes of the objects and the distances, but it's showing you the basic layout. Notice in terms of the shadows, the total shadow is something called the umbra, and then if you're standing in partial shadow, that's the penumbra. Okay. In terms of eclipses, the umbra is where you've got to stand for totality, so having the moon totally cover the sun. And then if you're not quite in that part of the shadow, then it looks like a bite's been taken out of the sun in terms of a partial eclipse. So this should occur every month, right? We have new phase every month. Doesn't happen every month, right? So we need more than this. We need it. So it is one of the things we need. We need it to be new phase. But we need more than that happening. So this diagram isn't showing us the entire story of what we need to have a solar eclipse. So let's go to the next slide.
Scott, I have a question.
Yep.
About that this time, yeah.
Sure. Yeah, feel free to ask questions of this.
What is the new phase? What does that mean?
Okay, so let's go back to the previous slide. So the new phase is the one you can't see. Okay, so full phase, you know what that is. Full moon, where you can see the whole thing illuminated. Okay, you're seeing the daytime side of the moon, right? So new phase is when the nighttime side of the moon is pointed at you. Okay, so everything in the solar system is illuminated on one side by the sun. So notice in the diagram here, the daylit side of the moon is facing the sun, but from the Earth, we're facing the nighttime side. Okay, so good point. That's technically what new phase is. Okay, so again, that's one of the criteria we need. We need to be looking at the nighttime side of the moon, not the daylight side. Okay, so why doesn't this happen once a month? Well, the moon's orbit is not in the same plane as our orbit around the sun. Okay? So the moon's orbit is tilted by about 5 degrees. Okay? So you can have the moon in new phase. So for example, so here the moon we'd be facing the nighttime side of the moon. So we've got new phase there. But since the orbit is tilted, notice what happens to the moon's shadow. It's missing us. It's going above the Earth. So most of the time that's going to be the case during new moon. That shadow is either going to go over the north of the Earth or below the Earth, below the south pole of the Earth. So most of the time it's going to miss. Okay? So that decreases the number of solar eclipses you're going to have. Instead of every month, it's going to be at a much lower rate than that. So you have to have new moon, and the moon has to be in the same plane as our orbit in the sun. So, for example, here we're meeting that criteria. We've got new moon, and the moon happens to be in the plane of our orbit around the sun. And so here, notice the shadow of the moon can now hit the Earth. Again, most of the time that doesn't happen. Most months it's going to miss us above or below. Now, some of this also applies to lunar eclipses. Lunar eclipses are when the moon passes through our shadow, the Earth's shadow. Okay? Now, that alignment doesn't have to be as perfect, but it still needs to be pretty close. Most of the time, the moon is not going to pass through our shadow either. So that's why you don't have a lunar eclipse every month either. So if the moon's orbit was in the same plane as our orbit around the sun, you'd have a solar eclipse and a lunar eclipse every month. But because of this tilt of the orbit by about 5 degrees, that's enough so that we don't have it every time. So you have to have the right phase, and it has to be on what we call a node here. So notice the orbit does pass through the plane of the Sun-Earth orbit, but it just plunges through briefly, right? Okay, so that's one of the criteria that we need, or two of the criteria that we need. Let's look at some other issues. The orbit of the moon, the orbit of the Earth around the sun, those orbits are not perfectly circular. And in fact, technically, they're an oval called an ellipse. And in fact, in terms of these orbits, the thing that is the bigger thing, it's not even at the center of the oval either. Okay? So you've got this oval, and this is exaggerated so that you can see how to demonstrate the out of roundness. So notice there's going to be times when the moon is closer to us. There's going to be times when the moon is a little bit further away. Now, the further away something is, what does that mean in terms of its apparent size? It's smaller, right? So sometimes the moon is a little bit smaller. Sometimes the moon is a little bit bigger because of this oval orbit. The same is going to be true in terms of the apparent size of the sun. Our orbit around the sun is also an ellipse. So sometimes we're closer, so the sun's going to appear to be bigger, and sometimes we're further away, and the sun is going to appear to be smaller. Now, it just so happens the the moon and the sun, as viewed from the Earth, are both approximately a half a degree wide on the sky. But because of this variation, sometimes they're a little bit less than half a degree wide, and sometimes they're a little bit bigger than half a degree wide. Okay, so there's some variation there. And that variation can be enough to dictate whether or not the moon can actually cover up the sun during a solar eclipse. Okay, so let's go to the next slide. So this is showing you the different possible differences, the maximum possible difference and the smallest possible distance just for the Earth-Moon due to the elliptical orbit of the moon. So you can see the difference in distances there. In terms of kilometers, you're looking at 360,000 versus 405,000 kilometers. And so that's going to cause the angular size to be a little bit different. And in principle, there's a special term for that when the moon is at its closest. It's called supermoon. You call something super, what's going to happen? It's going to make the news, right? How many people have heard on the news there's going to be a supermoon? Okay. Well, we'll get into that a little bit more in terms of how super it is or not. They never talk about the other one, the micromoon. And in principle, you should have the same thing with the sun. Do they ever talk about, go out today and see the super sun? I haven't heard that one, and I haven't heard anybody talk about the micro sun either. But in principle, those things happen, right? So let's go to the next slide. And then we can talk about how super any of this is, or how micro any of this is, right? So this is showing you the maximum possible angular size versus the minimum possible angular size for both the moon and the sun. Okay? So when the moon is closest to us, this would be an example here. So that's its angular size. So this would be the supermoon, and then this would be the micromoon over there. So that's a demonstration of the apparent size difference that you have there for the moon. Now, is that a big difference? It's not a huge difference. In fact, I'll talk a little bit more about that. We're not done yet. Now notice that you have the same thing happening with the sun as well, right? So when we're at closest approach to the sun's going to appear to be a little bit bigger. That would be the super sun, and then this would be our micro sun. So you can, if you stare at that, you can see combinations where the moon would not totally cover the sun, right? If you've got, quote, a micro moon and a super sun, the moon's not going to be able to cover the whole thing. It's going to cover most of it, but not all of it, okay? So if that's the case, when you've got new moon and the moon is in the plane of the Earth's orbit, you'll have an eclipse, but it won't be a total solar eclipse, okay? What you'll get is called an annular eclipse. You'll have a ring instead of the moon totally blocking out the sun. Okay. Now, I'll digress a little bit about the supermoon thing that I was making fun of. Again, the news will make big deal about the supermoons, right? And they'll say, go out, see the supermoon. Well, there's an effect that's going to be bigger in terms of your perception of how big the moon is. And the bigger thing is when you go out and see it, how high is it relative to the horizon? Your brain has evolved to make an estimate on terms of how physically big stuff is when you see stuff. And so when you're looking at, say, a bird going overhead, and your brain is interpreting that object is not very far from me, and say it's a half a degree wide, your brain is making a calculation about how physically big that object must be to be not very far away and to be about a half a degree wide. Okay? Now, when you look at something that's way off in the distance at the horizon, That object is how far from you? It's a long ways away relative to a bird flying over your head, right? Now, something that's a half a degree wide off on the horizon, your brain is going to do a calculation and say, that's a big object. Okay? Your brain is not telling you what the angular size is. Your brain is making some sort of judgment call on how big it thinks that object is. So what your brain is getting wrong with the moon is the distance to the moon. Okay? When the moon's over on there on the horizon, it's the same distance from you as it is when it's overhead. But your brain isn't thinking that way. Your brain has evolved to make judgments about terrestrial things. Okay? So there's an effect. You know, how many people seen the full moon rising and gone, man, that's big, right? You probably have all done that, right? Now, you've got a built-in measuring device you can use. If you hold your pinky out at arm's length, your pinky is about a half a degree wide, okay? So you can go out at any time and you can cover the sun up with your pinky, you can cover the moon up with your pinky. And the next time you see that big old full moon rising, get your pinky out and you can cover it. Okay? And when it's high overhead, you'll be able to cover it. Okay? And in fact, you can trick your brain into forgetting about how big the moon is as a terrestrial object. If you're just referencing it to your pinky, you can make the moon not look as big. Another thing that I've been taught is if the moon's coming up and you look at it through your legs, it's not going to look as big. And again, you're changing your reference, right? You're not referencing it necessarily to the horizon. So you can trick your brain that way as well. Anyways, so that's a bigger effect. So when the news is telling you, oh, there's going to be a supermoon, go out and see it, when are you likely to go out and see it? Somewhere near moonrise. Okay, and you're going to go, yeah, they're right. But, you know, go out when it's not a supermoon. You're still going to think it looks big. Okay, so again, the supermoon thing, that's something that gets overblown on the news. Okay, so now we're ready for the next one. Okay. So again, if you don't have, if you're in a situation where you've got a micromoon and maybe a super sun, then again, the moon is not going to be able to totally block out the sun. And you get something called an annular eclipse. So there's no place you're going to be able to stand where you're going to have totality. So again, what you need to have is the angular sizes need to be right. The moon's angular size needs to be at least equal to the sun or preferably a little bit bigger. And then you're going to get totality. So you have to have, again, new moon, has to be in the orbital plane of the Earth's sun, and then you have to have the right distance for this to happen. Okay? So all these things add up to you don't have a solar eclipse every month. Okay? Okay, so, yep.
Notes on the annular eclipse. If you were flying in an airplane and were closer to the moon, the eclipse would get smaller.
Now, you're right. It's probably going to take more than an airplane.
Well, yeah.
Yeah, you're right. You can get into the umbra here if you go up to a high enough altitude, right? If you get close enough, you can get into the umbra.
Is there a time in the total eclipse where if you went higher, that it would be covered more than you wouldn't even have a aura around?
Again, if you had a spaceship instead of an airplane, yeah, you could achieve that, right? So for example, we've got the Artemis probe thing on the way to the moon. When it orbits the moon, when it goes in the moon shadow, it's not going to see the corona of the sun, right? So yeah, it just sort of happenstance that these two objects almost have the same angular size. And you're right, the closer you get in, the more you're going to cover it up. Yeah. And like I said, I think you probably need more than an airplane to really to do what you're talking about. Yeah. Hold your breath and go up high in a helicopter. Okay. We'll go next on this. So this is a view from orbit of the moon's shadow hitting the Earth there. You can kind of see the umbra, and you can kind of see the penumbra there. The width of totality there is roughly about 90 miles wide. And then this thing is also moving on average about 1,000 miles per hour over the Earth's surface. The other thing that's going to happen in that shadow is, of course, the obvious is going to be dark, right? Because you're blocking the sun. But that also is going to have an impact on the temperature. The temperature is going to start to go down as well. So you're having a simulated sundown in the middle of the day, right? So if you're blocking the sun, you're blocking that solar radiation. The temperature is going to start going down. Not only that, the birds and animals are going to react to it as well. So how many of you traveled to totality in 2017? Were you noticing things like crickets and birds and everything turning on? Yeah. So everything is thinking, oh, it's nighttime. It's getting to be nighttime. And so you'll have that activity as well.
I was just down at Two Rivers Bridge, the Two Rivers Park, and they did that there with the parcel that we had.
Yeah.
All kinds of insects.
Yeah, and we didn't even get that dark. We were 90-some%, but even then we didn't get that dark, and he's observing some of that behavior there as well. Okay, next. So, like I said, you've got to have all of these conditions happening just right for a solar eclipse to happen. So they're not going to happen very often. If you pick a random location on the planet, on average, you're probably going to get a total eclipse once on average every 375 years. Okay? So these are relatively rare events for a particular area on the Earth. Now, you've got people that have the time and money that they are, quote, eclipse chasers. They will get on the plane and go to the part of the world where that shadow is going to be going across the Earth. Remember, that shadow width is only about 90 miles, so you've got to get yourself into that path of totality. This is a map of total solar eclipse paths in the time period from 1901 to 1950. And you can see, if you look at just Arkansas there was one in that time frame. And that was back in 1918. And from what I've been able to research a little bit, it was kind of cloudy that day. So if you were around in 1918 in Arkansas on that day, you didn't get a very good view because of the clouds that day. And so we can add weather to the criterion of whether or not you're going to see the eclipse as well. And we'll talk about that a little bit in addition.
When did astronomers, when did people figure out what was going on? That it wasn't just God angry with us or something?
That probably varies from culture to culture. What's interesting is you had cultures that were able to predict these without really knowing what was going on. So they were able to figure out that there are some predictable cycles here. And if you can nail that down, that is pretty impressive, A. And B, if you're the court astronomer and you can't do that, you might lose your head. And I think there's historical instances of where the court astronomer didn't predict the solar eclipse and he lost his job and his head, right? So back in the day when they didn't understand exactly what was going on.
Do you have any idea how they did predict them without the intimate knowledge of that today?
It takes looking at the cycles and being able to empirically look at you're looking at the data essentially in terms of when these are occurring and what the orientations of things were at the time. And then there's some empirical equations you can do to kind of fit that. So yeah, they're not using Newtonian physics and gravity and distances and everything to make the predictions like we do today.
So all they used was like a spreadsheet.
So essentially, a spreadsheet of the day, right? They're tabulating positions of things over time, and then they're able to empirically say, oh, I'm seeing a cycle here that it looks like this is happening every X number of years. And so they can, that's kind of how they were able to do that. But again, not going to happen very often for a particular location. 1918 was the last time we had in the state of Arkansas a total eclipse. There's been some partials that have been visible from this location, but not totals. Next. And then these are the totals from 1951 to 2000. So some of these, I've not been in the path of totalities of any of these, but I've been around for some of these in locations where there were partial eclipses. Okay? What you're seeing here, these, of course, are the paths where you've got to stand for the totality. If you're outside of that, you're still going to get a partial eclipse. Okay? So you might remember some of these. So I remember the 1979 one. I remember I was in Michigan at the time. I remember that partial solar eclipse happening, and some of the other ones. In 1991, I was living in Arizona. That totality path down there meant that we had partial eclipse in Arizona at the time, so I remember that one. And then maybe you guys remember some of the other ones in terms of being partial. One of these, there's a lyric in a song. Carly Simon, You're So Vain.
Yes.
You took a plane in Nova Scotia. I'm not sure which one it is. It's one of these. It might be that 1971. But you got that one on there as well. Let's go to the next one. So this one has the 2017 one that some of you went north of here and saw. And then this also has the April 2024 one that we'll talk about more. And then after that, it's not until 2045 that we're going to have one. Really in the United States, there'll be the 2044 one up here. But you're not going to have another one like the 2017 and the 2024 till 2045 for the United States and for Arkansas in particular. So next. And so this is looking back at the 2017 eclipse. Again, you had to go north of Arkansas. I think some of you went up into Missouri. So that was the path of totality there. This map is showing you what sort of percentages. And again, we were 90-some percent on that day for Arkansas. So we had partial, but we did not have total. Okay, next. So while you were out Two Rivers, I was up in the UCA Observatory on campus. I had the observatory open. We got a solar filter there. I also had a camera on there. So this was basically during move-in week on campus. So classes hadn't started yet. And in fact, unrelated to this, they always, on this day of the week, they always have a picnic for the students. So this was happening just serendipitously during that picnic on campus. So the university did buy eclipse glasses, and I'll talk more about that story here in a bit as well. And then I had some people coming up to the observatory as well to look through the telescope that day. So again, 90%, didn't get super dark, but it was still pretty interesting. Next. And then that's one of the pictures I took near the 90-some percent phase that we had here in Arkansas. Okay, next.
The blue, is that from a filter?
So yeah, I just used some Mylar, and that was a relatively short exposure too. So yep. Now, the other type of eclipse that I talked about in terms of solar eclipse were these annular ones where you have the ring, right? And these are some instances of those between 1951 and 2000. So there was one in 1994. at that time, I was living in Arizona. I didn't travel into totality on that one. Again, it wouldn't have been totality anyways, but I remember the partial on that one. That January 1992, I was actually in San Diego at the time for that one. And notice this cuts off because that was happening right at sunset. So technically, it was going annular while it was going down. Okay, this is the so-called Ring of Fire eclipse at that time. So I remember that one from that. Next. So 2001 and 2050. So notice we've got 2023, October 14th. Okay. And that's going to be kind of the next major eclipse. Again, this won't be a total eclipse. This will be an annular eclipse. So if you travel in the path here, you'll get the ring effect. Okay. So for that one, if you travel to visit that one, you will need the solar eclipse glasses for the whole thing. Okay. If you can see the sun, you need your glasses on. So the only time you can take your glasses off, your solar eclipse glasses, is if it's total. If the moon is covering the entire sun, then you're good. And these annular ones, you can't do that. You got to leave your eclipse glasses on. So if you're interested, you might want to travel to that. The good news is that's going to be kind of further south. The chances of decent weather might be better. Okay. Now we'll get a partial eclipse here on that date. Next on the slides. And in fact, this shows you what we're going to be at in terms of, for us in Arkansas, we'll be right around 75% coverage of the sun by the moon.
Scott, you said that with total, absolute total eclipse, you don't need glasses, but that's only when it gets to that stage.
Yeah, it's got to be, if you can see the sun at all, you got to have your glasses on. Yep. It's during that, when you have full coverage, then you can take your glasses off. That's what I'm saying with this. You're not going to be able to do that with this. You're always going to be able to see some of the sun. Okay? Or not, if you want that permanently tattooed on your retina. You can go online, if you Google it, you can see pictures of where people have tattooed on their retina the image of the eclipse they were looking at. So next on that one, this will be on a Saturday. From Arkansas, this is going to be the coverage that we're going to have. Again, we're going to be about almost 75% coverage. And it will be starting partial. We'll start at about 10:30. Mid-eclipse will be about noon on that one for our location. And so that's what we can expect for the next solar eclipse here. Next on the slides. In terms of weather, this is sort of guessing what the cloud cover will be along the annular eclipse path. And again, if you're going to travel, I would pick places where it's going to be clear. So this, New Mexico, places like that, the odds are going to be the best. Because it is a bit of a randomness there in terms of whether you're going to be able to see it. The weather is the final random thing. You can make your reservations and everything, and you can go, and it may be totally cloudy. It may be raining that day. Okay, so you're always taking a bit of a chance if you're traveling into the path. Okay, next. So total eclipses, again, the next one that we're going to have is the April 2024. This is the eclipse path here. It's going to cut right through Arkansas. And so that's the next big one for us. Next on that. Another thing about these eclipse maps. It's actually more binary than what you think. Okay? On some of these, they'll tell you what the percent sun coverage is. Really, it's all or nothing, right? There probably wasn't that, I didn't get very many oohs and ahs at 90-some%. I don't know where you were standing.
Oh, yeah, we did.
Oh, did you?
Yeah.
Okay, cool. But you really get a lot of oh my gods when you're in the path of totality, because as you guys saw, right, you've got a black hole in the sky, right? And so that's going to drive a lot of people into that totality, into Arkansas, especially if the weather forecast is good. We're going to have a lot of people visiting Arkansas that week. This is going to be happening on a Monday. So starting Friday, Saturday, Sunday, that weekend, we're going to have a lot of people coming in here. So even if you're not interested in the solar eclipse, just be aware that that's happening. You may have a hard time getting around that weekend. You may have a hard time getting to and from work on Monday. Okay? The traffic could get really bad, especially if the weather's clear. Okay?
That really screws up Interstate 30, doesn't it? That really screws up Interstate 30.
Well, it's going to screw, it's going to screw stuff up. Yeah, just up and down that. Yeah, you're going to have, and some of you that traveled north of here probably saw an inkling of that traffic, right? You may have had some traffic issues. I know other places for that 2017 that there was just major traffic snarls for a lot of it. So keep that in mind. Keep in mind you may have friends calling you. Can I come stay with you? Okay. People have been calling the hotels in Conway for a long time now. They could have those all booked up, but their system doesn't allow them to book that far in advance. Okay. As soon as those hotels are available, they're going to be booked up. They're probably going to be booked up in here in Little Rock too, for that weekend and on that day. Okay, next.
Well, imagine at the state parks.
Some of the state parks are making plans. Pettigene is making plans. Hot Springs.
I mean, all their cabins, everything will be.
Yeah. As soon as they make that stuff available, campgrounds, you name it. State parks, Hot Springs, they're making lots of plans. Pettigene is making plans. Conway is making some plans. I'd like to see more planning on their part. But here you can see just exactly which towns the path of totality is going to be going through. The other thing to keep in mind is if you're centered on that path of totality, that's where you're going to have the longest totality time. So for example, Little Rock, you're not going to get as long a totality as you're going to get in Conway. And Conway isn't going to get quite as much totality as, say, Clinton. Okay? Any of these towns that are right on, Russellville is really close. They're going to have longer totality than Little Rock and Conway is going to have. So you're going to have people wanting to get to that center of that path as well. So I expect on that day you're going to have people from Little Rock wanting to get to Conway, wanting to get to Clinton to have the longest possible totality. Okay. Next. And just another map again with the highways on it, so you can kind of see, I-40. You're going to have people coming from both directions, right? You're going to have people coming from west on I-40, east on I-40. They're all going to try to converge again, not only into the path of totality. They're going to want to get as close to that blue line as possible as well. Okay, so again, keep that in the back of your mind. Even if you're not interested in the solar eclipse, it could be busy that day.
Did you mention what time it was starting?
So we'll bring that up. We can go next on that. So this is the numbers for here in Little Rock. So Central Daylight Time, you're going to have the first of the partial happening at about 12:30. Okay, and then you're going to have it ending at almost 2 o'clock almost for the end of it. And then you're looking at duration for Little Rock, about 2 minutes and 26 seconds is going to be what the totality time will be. So this will be happening midday. Oh, actually, I've got it up there. So maximum totality right in the middle, you're looking at about 1:53. It will be the time. Next. Just as comparison, this is going to be the Conway number. So Conway, we're going to have about 3 minutes, 53 seconds. So we're going to be almost 4 minutes. Okay. So there's a significant difference between just from here. You'll have totality here, but it'll be longer elsewhere. And again, similar time, around 1:53 for the maximum. Next. Clouds, the last joker in the deck on this, right? Now, the serious chasers are going to be down there in Mexico, right? You're going to have the highest probability of clear skies. You can see as you go along the path of totality, it gets worse. We're not too bad. It's April. I'm figuring about 50-50. Okay? So, but you're still going to, so exactly how many people we get showing up is going to be a function of what that 5-day forecast is going to be. People will make that last minute decision. And so if it's clear, we'll have a lot of people. If it's predicted rainy, we won't have as many people show up. Okay? Next. Now, if it is cloudy, it's still going to get dark, okay? It's going to get even darker because you've also got the clouds. So it will get dark that day. So even if we don't have a bunch of people, you still might have people slowing down and stopping on Interstate 40, right? So just because it's gotten dark in the middle of the day and they're not sure what's going on. So even if cloudy, it's going to get dark for a little bit. Okay, next. Again, when do you need glasses? When do you don't need glasses? The only time you don't need glasses if it's like that. Totality, you can take your glasses off. But as soon as the sun isn't in totality, you're going to need your eclipse glasses on. So on the way in, partial, and then on the way out, partial. Okay. Now, if you've got eclipse glasses from the last time and you've stored them okay, they're probably going to still be good. Okay, I don't see any reason why they're not, unless you've stowed them someplace where they've been scratched up and stuff. So if you still have your eclipse glasses, just inspect them. If they're not damaged, you should still be good to go. If you haven't got eclipse glasses yet, it's a buyer beware situation. Let's go to the next slide. There are relatively few reputable vendors out there to get eclipse glasses. These are going to be in high demand, especially the closer we get. You're going to have huge numbers of these being ordered. In fact, UCA is just now getting around to trying to get an order in for eclipse glasses to hand out to students on that day. The best place to go is to go to that website there. The AAS stands for American Astronomical Society. So if you do a search on American Astronomical Society and eclipse, you should be able to go here, and then you can get a list of reputable vendors. Now, it can be difficult to verify whether you got a reputable vendor. If you do not use one of the ones on the list, you're taking your chances. Back in 2017, UCA bought a bunch of eclipse glasses. They were garbage. They were handing them out like a few days before. They started handing them out for free at the bookstore on campus, and I had a woman come over to my office with a pair. And she was somewhat skeptical of these glasses. And I said, well, let's take a look at them. So I had a good pair in my office, and I had the ones that she had. Now, from my office, I can look outside and see parked cars out there, and I can see sunlight bouncing off those cars. The bouncing sunlight should be the only thing I see through those glasses. But I could see people walking around. So the vendor that they used swore up and down and gave documentation claiming that these were legit. And they weren't. And so I think through some prodding and some threats of legal action, they got their money back. But just be aware on that. Next. And so that's what you want to see, right? That's the payoff there. You're seeing it just either coming out of or just going into totality. You're seeing just the last little bit of the sun's photosphere. This is the so-called diamond ring effect. And you can even see some solar activity happening here. And you're also starting to see that outer layer of the Earth's atmosphere called the corona. Okay? So that's what you want to see. Next. And if you look around, you may see some other things. It's going to get dark enough, you'll be able to see the planet Venus, you'll be able to see Saturn, Mars, Jupiter. There'll be a number of bright stars that you'll be able to see, like Vega, Capella, Aldebaran, and some stars like that. So don't necessarily look just at the sun during totality. Look around, you'll be able to see some of the other things happening as well. Next. In fact, it's during total solar eclipses, those are the best time to observe the solar corona. You've got this natural block of the sun's photosphere, and then you can easily see the prominences and various structures in the corona of the sun's atmosphere. And that stuff is dynamic. It can change while you're watching it. Were you guys able to really see the corona very well where you were at? Yeah. Next. Historically, solar eclipses were one of the first tests of Einstein's theory of general relativity. Einstein says mass bends space, and space tells matter and light how to move. And so near and around the sun is distorting space-time, and that will shift where the stars are on the sky, off in the general direction of the sun. So astronomers back in the day, was it 1919, they went out and found the first eclipse that they could go to verify that effect. And that's what you're seeing here. This is an article from that time testing Einstein's general relativity. If you're familiar with an effect called gravitational lensing, and in fact, if you saw one of these James Webb Space Telescope images with the arcing galaxies, that's the same effect. This is gravitational lensing. So this is one of the first tests of general relativity. Next. And this is showing the same thing. So where the star would be on the sky if the sun wasn't there would be the yellow dot, and then the red is where it appears to be due to the distortion of space-time around the sun. Next. Okay, so at least the following is my plans for that weekend and the day of. So what I'm going to be doing, the university is still in the planning phase for exactly what it's going to be doing campus-wide on that day. The university president has already made the decision of not having classes on that Monday, which was good. The schools probably aren't going to take that day off. And so who knows what the schools are going to do. During the partial in 2017, some schools didn't want the kids going outside. Okay, yeah. So, but if they didn't have eclipse glasses, you probably didn't want them going outside. So there's that issue too. So it's going to be a school by school thing in terms of the K through 12 in terms of what they do. They're probably not going to be able to take the day off. That would probably take legislation to make that happen. But what I'm going to be doing, starting that Friday of that weekend, I'll be doing more planetarium shows than what I'm usually doing. I'll be doing shows that will be simulating the coming eclipse and talking about eclipses and things like that. If it's cloudy that day, on that Monday, I'll probably be trying to do some live feeds from elsewhere in the planetarium that day. But if it's clear, it'll be like 2017. I'll be up in the observatory, but I probably won't have public coming up. What I'll probably try to do for this one is to set it up so that I'll live stream it out on YouTube so that anybody in the world can go and see our live feed on that. So that's if it's clear, I'll be doing that. Like I said, the university is still in the planning phases of what all they're going to be doing. The day of, they're probably going to try to do some stuff on campus even during that weekend. They may try to make a festival sort of thing out of it. So I can let you guys know once I know what we're doing beyond what I'm doing. So next. Again, here, these are just some links. If you're somebody with connections in Little Rock and want to get involved with planning, there is a white paper that you can find online for planning. I have no information about what Little Rock is doing or whether they're making any plans at all. I do know Hot Springs is making plans. I know Russellville is seriously making plans. Like I said, Conway, I haven't been impressed with how much planning that they're doing so far. But if you're interested in that, you might want to look into that. Next. So let me plug some of what I'm doing lately. Now that we're out of the pandemic, I guess, we were down from March 2020 to March 2022. I really didn't do any public shows in the planetarium, but since 2017, we've got a new planetarium on campus. It's called the Griffin Planetarium. Although if you just Google UCA Planetarium, you can find the info on it. I do shows typically Fridays and Saturday nights at 7 o'clock. They're 1 hour. They're free of charge. Seating to the first 94 people that show up. First half of the show, I typically do a tour of the current sky, showing you what's up in terms of stars and constellations and planets and anything else special that's happening. And then I also have what are 20 to 30 minute full dome movies on a variety of different subjects, most of which are astronomy related. We do have one on bears, grizzly bears in Alaska. But if you're interested in any of that, the schedule is at that website. I don't have the spring schedule up yet. We've got 2 more weeks in the semester that I'll be doing shows, but then once the semester starts back up, we'll be doing shows again there. And then next, I also try to do some public nights up in the observatory. We did one this semester. The weather was good enough. So first Monday of December is the next scheduled public observatory. And that'll be happening, I think it's 6 o'clock to 8 is when I've got that scheduled. And that's kind of an open house situation. You can come and go, and you can look through the telescope. Currently we got Jupiter up, Saturn up, and some other things that you can come view. But again, the schedule for that, if you just do a UCA Observatory search, you can find the schedule on that. But I think that's all I've got. Y'all have any other questions? I'll take questions. Yep.
I read somewhere that the moon's orbit is gradually getting larger.
Yeah, you're right. The physics on that have to do with angular momentum. Yep. Oh, okay. So Joe has asked the question that he heard that the Earth and the moon are getting further apart over time, and they are. There's tidal forces between these two bodies. If you're near the ocean, you're familiar with the tides, okay? That's due to a combination of the gravitational influence of both the moon and the sun. But the Earth also has tidal forces on the moon. And in fact, the tidal forces that the Earth has exerted on the moon has slowed the rotation of the moon down to the point where you always have the same face of the moon facing the Earth. Okay? That's why there's a near side and a far side. Okay? Now, these tidal interactions also go into the reason that they're separating, along with conservation of angular momentum. So to this subject here, there will be a time when you're not going to have total solar eclipses anymore. At some point in the distant future, the moon will be far enough away, it won't be big enough to cover the sun. But yeah, that's happened. I forget the exact number, exactly how many millimeters or centimeters per year, but the distance between the Earth and Moon is going up. Yep. So that wasn't fake news.
Is that just part of the expansion, the continued expansion of the universe?
No, that's a different ballgame. Yep. The gravitational forces between the Earth and the Moon, that's much, much larger than the expansion of the universe, stretching of space-time that you're thinking of. But
What about the distance between the Earth and the Sun? Is it also increasing?
I'm not aware that that's changing. So my short answer would be no, but I'd have to look it up to make sure.
Could we ask Sherry? Would she know?
Yeah. But, okay, any other questions? If not, thanks for having me.
Much appreciated. Much appreciated. That was a very informative talk. And I guess one of the main functions of the Arkansas Society of Freethinkers is to help people like yourselves get to know each other and to not live in isolation, staring at our phones or our TVs so much. So let's take a moment and say hi to the person next to you. Shake hands, fist bump, whatever you're comfortable with. And we'll just take a minute to do that.
We already treasure
A lot of old friends here. All right. So moving on, another way that you can meet new friends and get involved in your community is attending events or joining our group of volunteers and event hosts. You can attend any of the upcoming events. We've got some big ones coming up this November and December, including on the 27th, we'll be putting up the solstice display at the state capitol. Our legal team fought long and hard to get us the right to display our display there on the Capitol and to let the world know that we are here and we are real and we are organized. So feel free to come out to that. You can, of course, find this information on where to go and when on meetup.com. On Monday the 28th, we're having a very special pint night to give Byrne a good pat on the back and wishes of good luck as he goes in for chest cracking surgery. And that'll be in the basement of the Flying Saucer. Some of you old timers, that will be a return to a old pint night haunt of ours.
The party, not the surgery.
Yeah. To clarify. Yes. On Tuesday, the December 6th, we're going to have First Tuesday. Of course, the first Tuesday of every month, we meet up at the pizza place on McCain in North Little Rock, American Pie Pizza. And on the 18th, we have our next main meeting like this, and we'll have another get-together in the same spot on the 18th. Kind of right before some of you might leave for the holidays, but Maybe not, we'll see. So the brochures at the back table describe ways to keep track of ASF events. Meetup.com, just install the app on your phone, is the easy way to do it. I'm a little more nerdy, so I synced the calendar with my Google Calendar where I can look at my events and ASF events overlapping. It's not hard, I can help you out with it. And if you'd like to host an event, like a potluck or a book club, a families meetup, whatever, just let us know and we'll get you on the calendar. And we also have a need for people with skills, graphic design, website development. Oh my gosh, getting a call back on website development is tricky. And law or a number of other fields. Chances are if you have a skill, we can use it. We need volunteers to do lots of things. We've got big dreams. And we really appreciate you coming and hope that you will support us by joining the Arkansas Society of Free Thinkers and joining us at events. Got a question? December 11th is Second Sunday Cantina Communion. So that's where we meet up at a restaurant on Cantina Cinco de Mayo, Stagecoach Road, 6 o'clock. And so that was, yeah, I should have had that on my post-it note. But thank you all for attending, and it's good to see you all here, and we'll talk next month.